Hey everyone, today's video is going to talk about graphing quadratic functions. We've really been focusing on absolute value functions so far. We've talked about a few different ones, but then in the last little bit we've been talking about absolute value functions, and then we've talked about transforming them, moving them around on a graph, all kinds of different stuff about absolute value functions. So this time we're going to talk about graphing quadratic functions. So we probably need to know what a quadratic function is. A quadratic function has a standard form of f of x equals ax squared plus bx plus c. So a, b, and c are all numbers in standard form. So a quadratic function creates a U-shaped curve called a parabola. So that looks like this. So to get a little bit more familiar with these, let's use a graphing calculator and sketch these. Now, use your graphing calculator, use Desmos, whatever is easiest for you. But whenever you graph these, you're going to see that this one looks kind of like this. And the second one is going to look kind of like this. And I want us to just notice that we have ax squared plus bx plus c and ax squared plus bx plus c. All right, so something that we need to notice about this is if a is positive, then the parabola will open up. So this is a positive 1 for a, and the opening is at the top. If a is negative, the parabola will open down. So this is a negative 1 in front of x squared. So the parabola, the opening is at the bottom. You need to memorize that. Okay, now we want to learn some words. The vertical line that divides a parabola into two equal parts is called the axis of symmetry. So we have our parabola, and this line that we can make that divides it perfectly in half is called the axis of symmetry. The axis of symmetry formula is x equals negative b divided by 2a. And that is using the a and b from standard form. So we're using this guy and this guy to get this. Then we have the turning point of the parabola. So that is going to be this little guy. Oh, sorry. Right here. The place where it goes from, where it changes directions. That is called the vertex. When the vertex is the lowest point, it's called a minimum. So that's what this is. Whenever it's the highest point, it's called a maximum. So if we had a parabola upside down, it would be here, and that would be the maximum. So we're going to go back and label those parts on the graphs we just drew. All right, so let's make our axis of symmetry be teal. So that's going to be divided exactly in half. So in both of these, that's right here. And then we want the vertex. Let's make it purple. Why not? And that is the lowest or highest point, or also known as the turning point. And notice that that is always where the axis of symmetry intersects the graph. So let's look at some examples here. We want to determine whether each function has a maximum or minimum, then find the axis of symmetry and the vertex. So first we want to find if it's a maximum or minimum. Remember that if a is positive, so we have we have ax squared plus bx plus c. So a is the coefficient beside the x squared term. So if we wanted to make this look a little bit more like this, it would be 4x squared plus 0x plus 0. So when you're missing terms, those coefficients are zeros. All right, so since a is positive, that means our parabola will open upwards. That makes this a minimum. So we're going to have a minimum. Now we want to find our axis of symmetry. So to do that, let's use a different color. The axis of symmetry is x equals negative b over 2a. So b is 0 and a is 4. So we have negative 0 divided by 2 times 4. Well, 0 divided by anything is just 0. So this axis of symmetry is x equals 0. Now let's find the vertex. We made it purple. We'll stick with purple. To find the vertex, you take this 0 and you plug it in for x. So we have f of 0 equals 4 times 0 squared. So we use this and use this to solve. So we're going to get that f of 0, which is just the y value, equals 0 squared times 4, which is just 0. So the y value of the vertex is 0. And the vertex is a coordinate point, so it uses the x from the axis of symmetry. Now, this one is a little confusing because we got so many zeros in it, but we're going to keep doing this. We're going to look at the next one. So we have f of x equals negative x squared plus 6x. So we can add a plus 0 on here to have a, b, and c. A is negative. So we have a parabola pointing down, meaning that our vertex is a maximum. All right, that's step 1. Step 2, to find the axis of symmetry. We have x equals negative b divided by 2 times a. So here's b. Oh, actually, I just circled the letter. Silly me. Here's b, here's a. B is 6, so we have negative 6. A is negative 1. So this is negative 6 over negative 2. That equals 3. Our axis of symmetry is x equals 3. Now, when we find our vertex, we actually can just go ahead and say that the x value of the vertex is 3. We know that that's going to be the case. Now we just have to find the y value. So we plug 3 in for x to find what the y value of the vertex is. So we're using this, and we have negative 3 squared plus 6 times 3. So 3 squared is 9, so we have negative 9 plus 6 times 3 is 18. That's going to give us positive 9. So the vertex here is 3, 9. All right, number 3. We can rewrite this as negative 2x squared plus 0x plus 7. So we have a, b, and c. A is negative, so the arrows point down and we have a maximum. All right, now axis of symmetry is x equals negative b divided by 2a. B is 0, so we have negative 0 divided by 2 times a is negative 2. Well, 0 divided by anything is just 0. So our axis of symmetry is x equals 0. And then, of course, our vertex has an x coordinate of 0 from the vertex. And then we'll find out what the y value is by plugging 0 in for x. So negative 2 times 0 squared plus 7. 0 squared is 0. So 0 plus 7 equals 7. And that's what will go here. All right, for number 4, for this function, we already are in ax squared plus bx plus c. So we have part A, part B, and part C. A is positive 1, so we have A is positive. So the arrows point up, and we have a minimum. Okay, now we want to know the axis of symmetry. X equals negative b divided by 2 times a. So b is negative 8, so we have negative 8 over 2 times a, which is just positive 1. So negative 8 is 8 over 2 times 1 is 2, so we just get 4. X equals 4. And 4 is the x value of our vertex. So we need to find the y value. So we're going to plug 4 in for all the x's. So we have 4 squared minus 8 times 4 plus 9. 16 minus 32 plus 9. That gives us negative 16 plus 9. That's going to give us negative 7. And we're all done with the front page. All right, the next section, we're going to learn to graph these using a table. And it says we're going to use a table, but we're kind of going to use our calculators. I don't want to make it more difficult than it has to be. So we have our steps over here on the right. And first it says to find the axis of symmetry and write it on the middle row. So just for consistency, I'm going to keep using the same colors. Let's rewrite this in ax squared plus bx plus c so that we're 100% clear. 3, actually, we don't have to rewrite all that. We can just say plus 0x plus 0. All right, so our axis of symmetry, this is A, B, and C, is x equals negative b divided by 2a. So b is 0. We have negative 0 divided by 2 times negative 3. That's just going to equal 0. So we're going to put that in the middle row of our table. Did that. Now we're going to graph it on the calculator. Okay, so to graph on our calculator, we first click y equals. Then we can type our function into our calculator. We only have to type the original black part. And f of x is y, the same thing. So we're just going to type in negative 3x squared. Negative 3x squared. And hit graph. All right, so this is roughly what this is going to look like, but we want to get it perfect and we want to fill in our table. So we're going to hit second graph, and that will take us to our table. All right, so we have all of our x and y values. Now we want to make our table look like our table on our screen. So I just scrolled up in the x values. And if you look here, we have 7 choices and the middle one is 0. Look, 7 choices and the middle one is 0. So we want to make sure that we chose the right vertex. So we want to ask ourselves, do these rainbow each other? So here's our vertex, and then we should have the same 2 numbers, which we do. Same 2 numbers, same 2 numbers. Check. So that means that this is correct for our vertex, and that means that we can go ahead and use this to fill in our table instead of doing all the work. So I filled all these in straight from the calculator. I did not do any extra work on my own. So we have graphed on the calculator. We have gone to the table and found the vertex. We have filled in the rest of the table. Now we're going to plot the points and draw the parabola. I want to do this in this coral color because I want to try to stay consistent. All right, so we don't have negative 27 on here. We don't have negative 12 on here. We can only graph these 3 points. So negative 1, negative 3, left 1, down 3, 0, 0, and then right 1, down 3. So our parabola looks like this. All right, we have plotted our points and drawn our parabola. Okay, so now we need to fill in domain and range. The domain is always all real numbers for a parabola. And that's the symbol for all real numbers. The range is always y something something. And so we're going to have y. And then the first blank, if the arrows point up, then it'll be greater than or equal to. If the arrows point down, it'll be less than or equal to. Our arrows point down, so less than or equal to. Then the second blank is always the y value of the vertex. So the y value of the vertex is 0. So y is less than or equal to 0. And if we go to 0 on the y-axis, that's right here, and you'll see that everything on the graph is below that value. So let's try number 6 together. First, we're going to find the axis of symmetry and write it on the middle row. So we have x equals negative b over 2a. So we have negative 6 divided by 2 times 1. Positive 6 over 2 equals 3. So 3 is going to go right here. Now we want to find the rest of the values. So we're going to go graph this on our calculator. So now that we have found our x value for our vertex, or also known as our axis of symmetry, we are going to graph the function on the calculator so that we can copy down the table, because who really wants to plug in 7 different x values? So here is the y equals button. Here is the graph button. Those are the important buttons for this function. We need to clear out the one that's already there, and we can type in x squared minus 6x plus 11. And hit graph just to get a gander at this graph, see what it looks like. And there's what it should roughly look like. So, when we're done, we can make sure that we didn't completely screw it up. Now we want to hit second graph, which is table. So that takes us to the table so that we can fill in our table. And remember that we just want to make the x values, the x column, look just like our x column. So here we have a 3 in the middle of the x column, and here we have a 3 in the middle of the x column. We also have to check to be sure that our y values mirror around the vertex. So here's our vertex. We have 3 and 3, we have 6 and 6, and we have 11 and 11. Check. So we can go in and fill in the rest of these values from the calculator into our table and then graph them. Okay, we have a full table and we really didn't have to do a lot of work for it. That is fantastic. Okay, so now we need to plot these points. We don't have 11s on our graph, so we're not going to graph those points. Oops. But we can graph the other 6. Oh, 5. I'm really good at math. Huh. All right, so 1, 6. That's over 1 and up 6. Then we have 2, 3. Over 2, up 3. 3, 2 is over 3, up 2. Over 4, up 3. And over 5, up 6. So this is our parabola, or U-shaped graph with an ugly spot in it because I'm not perfect. Okay, so we have done this. Now we just need to talk about domain and range. Domain is always all real numbers. Woohoo, all done. Range is always y. And then the first blank says if the arrows point up, it's greater than or equal to. If the arrows point down, it's less than or equal to. Our arrows point up. So this will be greater than or equal to. And then the second blank is always the y value of the vertex, which is 2. All right, that's all for number 6. Okay, pretend that I did not say this part or this part or any of this part. I just want you guys to finish the rest on your own, and skip number 10. I was going to do more examples, but I really think you don't need them. And I know that as soon as you look at a video and it's 30 minutes long, that you are going to cry and then not do your homework until the last minute. So finish the rest on your own, skip number 10, use a calculator to check your answers. If you don't have a calculator, use Desmos, desmos.com/calculator. We've used it all year. Check your answers. Email me if you have questions. I'll be happy to do a Google Meet with you. Thanks and have a great day.